Good morning, all of you. Myself, Dr. Girish Dutt Gautam, working as an associate professor in the Department of Mechanical Engineering, IIMT College of Engineering, Greater Noida. In this lecture, we will discuss the IC engines, generally known as internal combustion engines. The general definition of IC engine is it is an engine in which ignition and combustion of fuel take place inside the engine. This fuel can be diesel or can be petrol. It works on the principle that the charge is ignited inside a combustion chamber under very high pressure. The combustion chamber is also known as cylinder. IC engines have numerous number of components. As shown in the figure on screen, we see there are many components. The major components are throttle valve, fuel injector, cylinder head cover, cylinder head, camshaft, rocker arm, valve, valve lash, adjustment element, exhaust port, crankshaft, position sensor, speed sensor, oil pump, oil sump, flywheel, crankshaft, connecting rod, piston pin, cylinder, crankcase, spark plug, piston, intake port, and intake manifold. IC engines can be classified on the basis of various parameters, in which two most important parameters are the number of working strokes and the nature of fuel used. On the basis of number of working strokes, IC engine generally classified in two types: two-stroke IC engines and four-stroke IC engines. While on the used fuel type, IC engines can be classified in three types: solid fuel IC engines, liquid fuel IC engines, and gaseous fuel IC engines. In the liquid fuel IC engines, the general used fuel is petrol and diesel. In the present slide, we see the structure of two-stroke IC engine, or we can say it is the two-stroke petrol engine. Here SI represents for spark ignition, as we saw a spark plug on the screen. The major components of two-stroke SI engine are spark plug, deflector piston, exhaust port, inlet or induction port, connecting rod, crank, crankcase, and transfer port. Now we will discuss the working of two-stroke SI engine or two-stroke petrol engine. As clear from its name, it has two working strokes. During first stroke, in the beginning of this stroke, the piston is at TDC. Here TDC stands for top dead center. It is the position inside the cylinder at which the piston can move upward and the mixture of petrol and air is available in combustion chamber. In this position, only the inlet port is kept open and other two ports, exhaust port and transfer ports, are closed. Then the mixture of air and petrol is sucked into the crankcase due to the vacuum created by the rotation of crank in crankcase. This is due to the upward movement of the piston when compression is in progress. At this position, the spark plug ignites the compressed charge. The combustion releases hot gas which increases pressure in the cylinder and a force is given on the piston. The piston starts moving downward. In the second stroke, the downward travel of piston from top dead center to bottom dead center, the inlet port is also closed, due to which the mixture gets compressed inside crankcase. The exhaust port gets opened from bottom dead center and burnt gases are exhausted to the atmosphere from bottom dead center. The transfer port opens, due to which the compressed mixture from crankcase enters the cylinder. The piston is given a special shape in two-stroke engines known as crowning of piston. This has the advantage that the unburned charge is deviated from going out directly with burnt gases through the opening of exhaust port. During this process, there is a very possibility that some unburnt charge may go with the burned gases. This is a great loss in SI engine, or we can say the wastage of fuel. Then the incoming fresh charge through transfer port also helps in driving out the exhaust gases. The driving out of exhaust gases by incoming fresh charge is known as scavenging. Thus, during the downward motion of the piston, the power stroke is completed and the crankshaft rotates by half revolution. The process is repeated again and again. From these figures, we see the both strokes in two-stroke petrol engine. The first one is upstroke and second one is downstroke. In upstroke, we see the fuel is compressed and ignited, while the transfer port is covered by the piston. In this situation, the inlet port is also open, then fuel mixture is drawn into the crankcase, and the crank is also moved in clockwise direction. Burning fuel forces piston down and compressing fuel mixture in crankcase. In downward stroke, we see the transfer port is uncovered and fuel mixture forced into the cylinder. Intake port is covered and valve forced closed. Thus, when the exhaust port is open, burned fuel is pushed out by compressed fuel mixture. In the two-stroke CI engine, here CI stands for compression ignition, also known as two-stroke diesel engines. In the first stroke, the piston occupies top dead center position. At this position, only the inlet port is open and the other two ports are kept closed. The amount of air is drawn into the crankcase from atmosphere due to the vacuum created due to upward movement of the piston. At the end of the compression, when the piston occupies TDC or top dead center, the pressure and temperature of the air become very high. Then the temperature achieved after compression becomes more than the ignition temperature of diesel due to high compression ratio between the range of 11 to 22. At that moment, diesel is injected in an atomized form into high temperature compressed air. The supply of diesel is made by the injector, which is fitted in cylinder head. As soon as the diesel particles come into contact with the compressed air, they catch fire. During the another stroke of two-stroke diesel engine, the combustion of fuel starts and the force is exerted at the crown of the piston. The piston is pushed down. During the downward motion of the piston, the inlet port is also closed, due to which air is compressed inside the crank casing. The exhaust port gets opened from bottom dead center and burnt gases are exhausted in the atmosphere. The transfer port opens from bottom dead center and compressed air enters into the cylinder. Because of the special shape of the piston head, the air is deflected and thus prevented from going out directly with the burnt gas through the exhaust port. In addition, the deflected air helps in pushing the exhaust gases out. This figure shows the schematic diagram of two-stroke CI or diesel engine, in which we can see the nozzle is used or the known as the fuel injector. Now we will discuss what are the major differences between spark ignition engines or petrol engines to compression ignition engines or diesel engines. The primary difference is spark engines draws air fuel mixture into the cylinder during suction stroke. It means the mixture of petrol and air enters into the cylinder, while in compression ignition engines it draws only air into the cylinder during suction stroke. Petrol engines operate with low pressure and temperature. Diesel engine operate with high pressure and temperature. The pressure range of SI engines are from 6 to 12 bar, with temperature range from 250 degrees centigrade to 300 degrees centigrade, while the pressure range of CI engine is from 35 to 40 bar, temperature range from 600 degrees centigrade to 700 degrees centigrade. Petrol engines is fitted with carburetor and spark plugs, while CI engines is fitted with fuel injection pump and injectors. The burning of fuel in petrol engine or SI engine takes place at constant volume, while the burning of fuel takes place at constant pressure in diesel or CI engines. In petrol engine, the ignition of air-fuel mixture takes place by an electric spark produced by a spark plug, while in CI engine, the ignition of air-fuel takes place by an injection of fuel into the hot compressed air. The other difference is petrol engines are quality governed engines. The speed of petrol engines are controlled by varying the quantity of air-fuel mixture, while diesel engines are quantity governed engines. The speed of diesel engines is controlled by varying quality of air-fuel mixture, rich or weak mixture. Petrol engines are widely used in small vehicles like bike, cars, scooties, while diesel engines are widely used in heavy vehicles such as bus, lorries, trucks, etc. Now we will discuss the four-stroke SI engine or the four-stroke petrol engine. As we see on the screen, there are four different strokes. First one is suction stroke, second is compression stroke, then power stroke and exhaust stroke. During suction stroke, piston moves TDC to BDC and the mixture of petrol and air enters into the cylinder, while in this condition exhaust port is closed. During second or compression stroke, the piston starts moving from BDC to TDC. Both valves are closed at this position and the mixture of air and fuel is highly compressed. Then in the third stroke known as power stroke, both valves are closed and the spark is ignited by the help of spark plug. The fuel starts burning and the piston starts moving from TDC to BDC. This stroke is also known as combustion stroke. After the burning of fuel, the inlet valve is closed and the exhaust valve is opened and piston starts moving from bottom dead center to top dead center and the burnt gases are going outside from the exhaust valve. This working can be also explained by the pressure volume diagram. Initially, there is some air inside the cylinder, so it has some volume and pressure. During intake stroke or the suction stroke, piston moves from TDC to BDC, or in the figure we can see piston moves from 0 to 1. After that, in the second stroke, the adiabatic compression is starts of the air-fuel mixture and the piston moves from adiabatically from bottom dead center to top dead center. When the compression is end, sparking from spark plug during the third combustion or power stroke, the heat is added, or we can say the spark plug ignite sparking. Uh, After sparking, the fuel starts burning rapidly and the piston moves from top dead center to bottom dead center. This stroke is known as power stroke, and in this condition, the expansion is adiabatic. When eh, when the combustion is completed, the exhaust valve is open and the heat is or the burnt gases are going outside the cylinder and the piston in this situation is at bottom dead center. And to completely remove the exhaust or burnt gases from the cylinder, piston starts moving from bottom dead center to top dead center, or from this diagram we can see the piston is again at the point of zero or at the initial point. This cycle is known as Otto cycle, or we can say it is the constant volume cycle. On the other side, the working of four-stroke CI engine or diesel engine is also performed in the same four strokes: intake or suction, compression, power or combustion, and exhaust stroke. But in the diesel engine, there is no spark plug, only fuel injector is used. In the suction stroke or intake stroke, piston starts moving from top dead center to bottom dead center. In this condition, inlet valve is open and the only air enters into the cylinder while the exhaust valve is closed. When the piston completely reach at bottom dead center, the second compression stroke is start. In this situation, piston starts moving from bottom dead center to top dead center, and the air is highly compressed. The highly compressed air has increased temperature. In the third, power and combustion engines, when the fuel or diesel is injected on the compressed air, it starts burning instantly. And at this condition, sudden explosion is held in the cylinder and piston moves from top dead center to bottom dead center. When the combustion is completed, the exhaust valve is open and the piston starts from moving from bottom dead center to top dead center, and the burnt gases are moved outside the cylinder from exhaust valve. We can also explain this working by pressure volume diagram. Initially, we see the piston at the condition of 0. When in the suction stroke, piston starts moving from top dead center to bottom dead center and air enters in the cylinder. When the suction is completed, the piston starts adiabatically compression of the air, and in this situation the pressure is increased while the volume is decreased. And when the compression stroke is completed, the fuel injector starts sprinkling the fuel diesel particles on the compressed air, and in this situation the volume is increased while the pressure is constant. And at this situation, when there is automation held, the diesel is explode instantly, and the piston starts moving from top dead center to bottom dead center. And when the piston reaches bottom dead center, the burning is completed or the combustion is completed, the exhaust port is open and heat is or burnt, the burned gases are go or move outside the cylinder. And when the exhausting is completed, the piston is came from its original position at top dead center. This cycle is known as diesel cycle and also known as constant pressure cycle. All diesel engines are working on this cycle. So in this lecture, we discussed about the two-stroke petrol engine, the two-stroke diesel engine, and the working of four-stroke petrol and diesel engines, also known as CI and SL engines. Thank you.